emits some assembly-like stuff for what's in the square brackets, and then whatever register that was, we multiply that by this constant. So, and that's ending up in size register. So size register is how many bytes it is. And then we do this bytecode malloc. And you know what? We're going to set some options. We're going to have a clear So I can say this instruction's options equals well, if is non-dynamic array, the options equals 1, this means clear the memory, else the options equals 0. So this options slot, it's an extra little word that goes into this bytecode instruction that then the malloc bytecode can interpret. This means do not clear. Oh, right. And I also need to check that flag that we don't set yet. This explicitly right, it was the other one. So we call it CMD here. Oops. So if we're not asking for it to be uninitialized, set the options to 1. So now we go to bytecode runner. Actually, let me make sure that compiles. Okay, it does. We're looking for the malloc bytecode, so this is what we run. We get the size, int options equals record register. Wait, that's not what we want to do. We just want to say SSA options. And you know what? We'll call calloc, because why not? If can't type options, clear the memory, else do not clear the memory. Okay. So that should be the bytecode new. Oh, calloc takes, so lame. All right. So now that is the bytecode new case. So back last time we ran this, then at compile time, these numbers came out wacky. And hopefully it doesn't crash, but the numbers come out correct. Yes. Hey, look, it worked. Zeros. So now we just have the bytecode local case left. Which should be interesting. I might have to add a new bytecode instruction that just says 0 memory or something. How does local work? I don't even remember how it works. Like if I, oh, right. So I have a, yes, okay. So I need to look for, oh, and I'll have an array initializer, right? Hey, look, I used to be thinking about this. Okay, so if I have a local declaration, okay, first before I do this, let me go back to our test case, and instead of newing these are going to be on the stack again. And let's see what even happens in bytecode. Attempt is, oh. Okay, so the bytecode is once again messed up because now we're on the stack. That's great because that's what we want to fix. Okay. So else if is non-dynamic array. What am I even typing? I don't even know sometimes when I do these streams like where my fingers are going. Okay. Emit code for, no, I'll just inline it. So we're going to want, okay, so we have a register up here that points to the memory already, right? So if it's stack allocated, which it will be in this case, I think, always, then there's an instruction for stack plus constant. You know, we have the base address from the stack pointer and whatever. So I can make a new bytecode that says instruction bytecode clear memory starting at memory pointer register for, oh, we need to get the size again. I should factor that into a function. Yeah, I should. And then the last argument is going to be -1 because there's no result register. It's not going to do anything. So let's go back to our C converter. And remember we had this thing, num array elements, and we computed that, and then we multiplied it by the size. I'm not going to try to factor this into it right now, but I'm going to make a function for it. So int num bytes equals computes that non-dynamic, use the same terminology, array size for this declaration. And I'm going to start typing this as a local function just because it's convenient. I'm not really going to do it as a local function because you can't really do that in C++ very well. So I'm going to say, oh, you know, I mean, I'm going to use a different format. So I probably need this to be 64-bit because I want to be able to handle big arrays. And although a big array on the stack is like, you can't do that, right? Your machine will crash. But I just want to, you know, in case we factor this code out into something more general. So I have this format where if you want to put a 64-bit value in the bytecode, you leave the middle two clear and then you set it. So I say, what is it? Big constant, right? So here I have an assigned to big constant where I leave the middle slots -1 and then this thing plops in there. So right, equals num bytes. So this is going to be an unsigned 64-bit integer. So we're going to have that compute non-dynamic array size as declaration for a decal. Why not? I'll do it all U64 this time. In the C converters, where did it get the count from? So all this should have been cleared by here, so we're going to assert defen and defen type inst, because we shouldn't have gotten this far if those things were null. We do a count. We multiply the array elements out, and then we gotta multiply it by the element size, which probably also should be 64-bit, but I'll fix that later. Whatever. Array element type, inferred type size, element size greater than or equal to 0, num, well, just return num array elements times elementop. All right, so I'm going to paste that way up here. I'm just going to remember that that's there for future use, so if I can factor other code into that, I will do so. Okay, so I need to define this bytecode before we will even compile. So bytecode, I'll put it here because it's sort of related. Clear memory, and I have to go into bytecode.cp, whoops, bytecode builder, and I have to put the string name because C doesn't give me an automatic way to do the string name, so this is for debugging purposes. We output that stuff. So now, hopefully, if we get it compiling, so we're at least adding that bytecode instruction, but now when we try to run it, it should fail to run because we haven't told it how to execute that bytecode. So it should say there's a bytecode I don't know. Yeah. So here we go. Unhandled SSA instruction clear memory, which is what we wanted. So now we go into bytecode runner. And so after malloc and free, we can put bytecode clear memory. Malloc free clear memory. And then let me look at how Emacs is barfing. Let me look how big constant did it, right? Because remember, that's just a bug checker thing, that check register. So we just look in big constant.u64, right? So now that's not really a result register, remember. It's sort of the result if you think of like, here's where the cleared memory is now, but it's also the input register because a big constant is taking up the rest of the space. So we want to say yeah, basically exactly what this is doing, except it's index result. So registers can hold, you know, integers, pointers, floats, or whatever, so it's a big union. And we're saying register number whatever has a pointer now. That gives us memory, and we're going to memset memory. Of course, memset doesn't take 64-bit. So whatever. We're just going to assume for now I don't know if there's somebody out there, if you know how to memset more than 32 bits of memory, let me know. Aside from writing a frickin' loop. Memory 0, SSA big constant dot U64. Hopefully that does something. It could crash horribly if I screwed something up. Look, there's 0. Let me make that memset be FA or whatever for, let's go AF this time. So the integer will at least, there we go. So it's working. So I'm going to assert for now, auto num bytes is this. And I'm going to assert num bytes is less than. Wow. Right. So that'll at least document that it's not implemented. So that's pretty good. I would feel okay to go home at this point. I'll go a little further, but so we got all these. That's cool. The array of structs is not necessarily handled. But since we've got all these, I want to add the uninitialized part. And then once the uninitialized part is added, then I'll do, some other day I'll do this stuff down here. Memset takes a size t. What is a size t? Is a size t 64 bits? I think it's just implementation dependent, right? Unsigned integer type 0 is the size z, the maximum size of a theoretically possible object of any type on many platforms, any oh, okay. Well, so maybe it's just not a problem. Maybe it's not a problem. I'm going to take that out. All right. So let us make a new token. So what I think I want to do is I want to be able to say like this. Like that right now means uninitialized. And you say equals that, and it's just a shorthand for hey man, don't initialize me. Don't tase me, bro. So first I need to make that an operator. And I already have, oh, I don't have a minus minus. So this is for the dash arrow like you get for lambda. And I don't want to use minus minus for this because like that's a little overloaded, right? In the sense that C and C++ use it, and maybe we'll use it for something, I don't know. So, okay, so when you have a dash, you could have an arrow, you could have another minus, or you could have this, right? Okay, so peak next character. Now I'm going to make a token for double minus, even if we don't use it in the language right now, because we might be able to use it in error reporting, like, oh, you put 2 minuses instead of 3, you know. Okay, so token double minus, token triple minus, double O, I'm secret agent double O negative. Okay, if next is equal to another minus, that's the third minus, we eat the character, And result equals make token result type equals token triple minus, else it's only a double minus. Okay, that should handle that in theory. So now, if I try to parse that file, though, because we don't tell it what to do with that token, it should say like unexpected token at this line number or something, right? Ooh, error in unary expression. That's no good. Maybe that didn't work. Did I recompile the compiler? No, I didn't compile the compiler. There we go. Okay, so that's, unexpected symbols at top level is about the best that we could expect, because we didn't tell it what to do. But now we're going to go back to that parse declaration function like we were doing. We keep coming back here all the time. So we've got an ident, whatever. So if the declaration includes a value, whether it's const or not const, we can look at the next token, right? And remember, we were already peeking at the next token after the equals because, right, it might have been like enum whatever, right? And we already needed to know that. So this is great because we can just say, I did all this groundwork yesterday, right? Else, if token is token triple minus, I probably shouldn't call it minus, but it's not really what it is. If it's token triple minus, then we don't really have an expression, right? We eat the token, and we say this is in a declaration, right? So we're going to find declaration is explicitly uninitialized. Can you tell I like big identifiers? Decl, well, except here, it's called result declaration flags or equals that. Now, I also want this to work on like constants, and I think back when we just did the equals 0 for floats and ints, not in the arrays, but at the very beginning of tonight, just for the scalars, we didn't have this flag yet. So I need to go do that, right? Here, we're still here in this file. It wasn't quite there, actually, I lied. Okay. Here we were. These are still our odd numbers. I'm going to write down change the weird numbers. But I'm going to keep them in because it's good for debugging. Okay, this should only happen if also the declaration flags are not explicitly uninitialized, right? If it's explicitly uninitialized, we do not want an expression. Oh, by the way, I also realized here we're not doing like bool or string, so that needs to happen too. Or pointer. So I'm going to go to bed tonight before we do bool, string, or pointer. Yeah. Compilers. At least we've got the framework in and it's easy to plug this stuff in afterward. Okay, so I should even be able to test that if I go back for a second, and I'm going to not do these yet. I'm just going to do that and whatever. So, and I'm not even, so I'm going to say x colon int, right? Oh, no, you know what? This is just going to be an extra test case that it works for ints as well. Okay. So all these should get initialized because we're not using the uninitialized thing. So let me just test that. Okay, yeah. Remember 113 was our funny number for integers. So that's getting initialized. So now, though, I want to be able to parse this. And I'm doing the int first because that's a simpler parser situation. So if something goes haywire, it'll be easier to debug. And hey, look, it just worked, right? The C compiler is complaining that x is uninitialized and we're using it. Of course, now it's got 0, but we know it's not our funny number, so we know it's not initialized, right? So that's good. That works. So let's go back to this. Okay, wait. So these are, remember, these are happening in the bytecode with mem set to 0 and in the C code with our spoo malloc. So this is going to be 0. The funny values are only for scalars right now. So if we put back this uninitialized, then we should get more whacked numbers. Except maybe the bytecode isn't doing that. I don't know. Why didn't that work? Okay, so the C code is correctly not initializing because we're getting screwy numbers. The bytecode is giving us 0. So it doesn't completely 100% work, or we're getting lucky and getting zeros everywhere. I don't know which of those is happening. I'd be suspicious. Let's just go in the bytecode. Maybe I just forgot to type that. And so that's for new. Oh, I'm not checking. Okay. Remember our bytecode clear memory that we just did. I didn't check this. If not, declaration flags and declaration is explicitly uninitialized, then we do that. All right. Hey, look, we've got garbage in our bytecode now, which is exactly what we wanted. So that makes me happy. So this is a feature that I wanted in this language, and it's now at least there enough to say that it's there. There's probably some corner implementation cases that don't totally work yet. And I need to basically write a file full of tests that tries like everything. But I can, I should try struct members. Oh God, that probably doesn't work. Totally. Okay, let's try this for individual struct members now. Let's get rid of all this stuff. Remember all these that we were doing up here. So right now, if I compile this, those should come out to our funny values again, right? Our 69105.1 and our 113 or whatever it is. Yes. So that's at bytecode time, and that's at compiled time, or runtime, right? So that's still working. Now I should be able to say, you know, the binding of Isaac actually should be uninitialized. So right now the binding of Isaac is 113, but let's hope that it's not. Hey, look, the binding of Isaac is a big garbage number, whereas the rest of this is there. Runtime. It's also, yes, so it worked. It worked. So that's cool, right? So the last feature, I'm not going to try to do this tonight, but the last feature I want to be able to do is I want to be able to locally override a constructor. So, you know, maybe on your vector or something, you initialize it to 0 all the time, but I should be able to say like a hello equals that. I don't think this is actually going to work. Maybe it does. Wow, it worked. Okay, I'm tired. I didn't expect that to work. So that's pretty cool. Oh, let me do this. Okay, so now I'm giving it real values. Oh my God, this is so great. Okay, I'm honestly not sure why this worked, but it totally did. Because I thought that this wouldn't override calling the implicit constructor, but maybe I did put that if statement in the right place. Okay, wait. Hold on. Okay, yeah. So now it's got all our values that we expected. We're printing Binding of Isaac in decimal and not hex, so it doesn't come out to a neat pattern. Although that should be more digits. Oh, we're printing it as a %d, not a %LLD. That didn't matter. Dude. I don't even, like, printf just, what? Well, we've got part of it. I don't, printing big numbers in, oh, I'm casting it to int. That's why. Let's not do that. Let's just let the Binding of Isaac be as big as it wants to be. Okay, so there we've got the whole number. Let's put the OX in front of it. All right. Yeah, whatever. Hey, it's going to look like Visual Studio now with all the zeros. So these are the values that we expect, but I can override this and set it to uninitialized. That didn't work. I thought that worked. Okay, that works in the C code. It doesn't work in the byte code. It doesn't work in the byte code. This is at compile time. This is at runtime. So I just have to make it work in the byte code. So code for implicit constructor. Okay, which version is this? In a declaration, so that is the one that's going wrong. For implicit, okay. So we just don't want to do this bytecode instruction if, or emit this and then this. It's a lot of instructions maybe. We just don't want to do this if we equal dash dash dash. So we want to say and not, and I'm just going to copy this, has explicitly. It's a lot. Took enough time to do that I might as well have typed it, but I'm saving myself carpal tunnel. Okay, so if we're not asking for it to be explicit and initialized, and it has an implicit constructor, call the implicit constructor. Hey, look at that. Awesome. Awesome. We got garbage numbers everywhere, which is what we want, because garbage numbers means our program goes fast. And if I take that back out, we should get all our explicitly initialized stuff above in both modes. There it is, it's right. And there it is, it's right. This has been a day of victory. Now, the last thing that needs to happen, though, is so far we can say equals dash 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 in a declaration, but we need to be able to say it in new as well, right? Because, like I said, new is not a declaration, it's an expression. So I need to be able to either say new dash 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 hello or new hello dash dash dash. And so think about which syntax you like better between these two. And I'm going to refill my water for a second, and I'll be right back, and we'll see what people think is better. Which of those would you rather say I want a new uninitialized block of memory with? Okay, what do we think? I see one vote for after because of easy edit approach, which makes sense to me. There's a straw poll. Oh, I lost it. Twitch chat sucks. Straw poll. It's 3-0 to put it after. Four. All right, so we'll do that. So this is going to be the syntax. So let's do it without this, right? Verify that all that still works. Okay, yeah. So all that still works. I'm going to take out that X for now, because we'll just comment it out. So we're getting all our values at compile time, and we're getting all our values at runtime. So that all still works. So now, if we put this here, we're going to get a parse error because the compiler doesn't understand it yet. I didn't expect it in declaration. All right, well, we didn't recompile it, so. All right. So now We go back into the parser, and we look for keyword new. We parse a type instantiation. This is going to be pretty straightforward, this part. So after we're done parsing a type instantiation, there may be a token after that we care about. So we say, do we have a token locally scoped? Yeah, so we'll say a token, well, let's copy this line, save a little typing. Token is lexer peak next token. If token is type is equal to token triple minus, then we eat the token, and we set that flag new is explicitly uninitialized. Asked new flags or equals new is explicitly uninitialized. So that should be all we need to do to parse that. Now, I don't remember where we actually check this flag. I'm sure it's not everywhere. So we'll parse it, but it probably won't work correctly yet. Okay, so we parsed it. We compiled the program. In bytecode, it's still initialized. So that one didn't work. So, you know, it's a little, I was thinking about this, it's a little annoying that I have to do everything twice right now. Like I have to do the C version and the bytecode version. Eventually, if we're targeting machine language through bytecode, then that goes away. You can drop the C version, at least. You know, you might want to provide it as a feature for people that they can migrate to C eventually if they decide they don't like your language or something. But you don't have to like maintain it as hardcore to make sure your compiler's working, because you just emit bytecode and then generate the machine language from the bytecode. But in the interim, I kind of have to do everything twice. But you know, you just have to be twice as good of a programmer, and then you can do everything twice in the same amount of time that it might take to do it once. Okay. What was I? Okay, so we need to. Oh, I want to run this to see. Okay, so it doesn't work in either place right now. We're not paying attention to that flag in either place. I should also check it. I don't know. Let's do C first. Ask new or delete. If command new flags and new initialized use constructor equals false. Okay. So now that still doesn't work, but that one works. So now let's do the bytecode. Bytecode builder. Implicit constructor. If, let me go copy this. Explicitly uninitialized. Who goes into their language and adds features for uninitializing things? That's crazy. If not decal. Oh, I have that down there. Okay, well, this is weird. This is the wrong case. This is the wrong case. Because I'm checking this down here. I just put that in like 5 minutes ago. I should remember that. So, oh, this is a declaration. This is not the new version. This is the declaration one. So we have to go here, ask new or delete. Okay, so here's where we checked that for clearing the memory, but right? We also don't call the implicit constructor. There's no explicit constructors right now. There's only implicit ones. So, all right. There we go. Garbage numbers, garbage numbers, garbage numbers. Okay, so that's actually a very nice feature because this is sort of, in my opinion, I feel like this is the way that values should just work in a programming language, is you get a default value that you can use always unless you don't want it for performance reasons, right? It's a swap default from the way that C works, and we've managed to do that tonight in 3.5 hours or whatever it's been. Wait, no, we started at 8:15, so it's been 3 hours and 15 minutes. So that's pretty cool. Like I said, there's probably some corner cases. Oh, the U8 versus S8 thing doesn't work. We have our funky values of 69,105. I'm going to leave that in there so that when I debug the U8, S8, and all that later, we still have the funky values to help. I need to implement, it's not related to this feature, but I need to implement initializing a dynamic array when you make it with new, because remember we spotted that comment that that's not implemented. Why do I prefer Windows over Linux? Because Linux drives me nuts. It's impossible to even get Linux fucking working. I can't use it. Linux, I've gone back to Linux every few years. Like I started using Linux in 1991 or something with Slackware, and for a while it was getting better and more exciting. These days Linux is worse than it was 4 or 5 years ago. Like it's just a disaster, like nothing works, and people just keep making it more complicated and more distros and stuff, and it's like the distros that are there don't work. I had to try like 4 times to even get it installed on my laptop, 4 different distros. They were all just failed. And then once it works, you have all these problems, like I'm trying to run Linux Mint Cinnamon and like the locks up all the time and it's a disaster. Yeah, anyway. You can watch the earlier videos. Oh, would a complete function declaration be that thing that you typed? Yeah, basically, but you don't want to have to type all that stuff, right? So you can leave the middle part out. Dude, connects 0. If you start trash talking me about Linux, I'm just going to ban you because it's stupid. Like, look, Linux is a pile in terms of usability. That's just how it is. I mean, I wish it weren't, right? I would like to get off Windows and use a free operating system, but my God, Linux people have to get their situation together. I have a lot of laptops actually, but the one that I was demoing off in the demo the other day, and the one that I use every day usually, is the Razer Blade 14-inch from 2014. You know, the new one with the high-res screen. Am I thinking about implementing compile time functions for manipulating the AST? Yes, I am thinking about it. I'm not sure if that's the best thing to do. It's a little scary because people can just like program in any language they want at that point. But it's also very powerful, and maybe it's the right thing to do. So I want to think about it. But in the meantime, I want to get some of these other features in, like these garbage numbers that I'm so excited that we can print out now. What are my thoughts on function overloading? We probably want to have it for various reasons that I'll explain, having to do with the object system. Object system used very loosely. I should come up with a better word for that. Have I done or thought about pinning vars to CPU registers yet? No, that is a much lower level thing than I am thinking about. At some point the time will come to actually target generating machine code. That time is not yet. For now, I'm just working on the semantics of the language. I'm just whipping out my laptop now, and I'm going to update. I'm going to pull all the code from there onto there, and it's pulled. Twitter's kind of quiet tonight. Oh, no, it's not. Oh, yeah, it is.